So now the instruction format is there are quite a bit of instruction formats here in RISC-V. So the first one is what is called the R format. So the R format instruction has this 32-bit format here. So I'll just describe one operation here. So you have a 7-bit opcode, and then you have the destination field, which is RD. This is a 5-bit field. Then you have what is called a function 3 field. Then you have the two source registers, RS1 and RS2. Then you have another function field. Now, if you have, for example, add instruction such as this. So let us go to the next slide here. So the add instruction has a certain opcode. In fact, all R-type instruction have this particular same opcode 0110011, whereas their function fields are different, and this function 7 field is also different. So why do they have so many fields? Because they had so many R-type instructions that they cannot just use just the function 3 field, and they probably also want to allow extensions. Therefore, they have another function 7 field here, which is basically a 7-bit field, and this is a 3-bit field. That's why this is called function 7 and this is called function 3. And to allow for extensions to this architecture, they probably have allowed another set of function fields here. So basically, you distinguish between each R-type instruction with the help of the function 7 and the function 3 fields. So if you have an instruction such as add x9, x20, x21, so how would you interpret this? So you never have to write this on your own. So you have compilers which do this. So you have RISC-V cross compilers which will compile this into an assembly, and also assembler which will which will convert the code into the binary. But then if you're ever going to write a test bench, for example, you need to at least know how these fields are written out. Therefore, let us try and do one instruction here. So you have x9, x20, and x21. So you have the two source registers RS1 and RS2. So you're going to fill up the 5-bit equivalent. So I'm sure you know why this field is 5-bit, because there are 32 registers, and therefore this is a 5-bit field. So the mapping is quite simple. So if the register is x0, then you're going to indicate that by 5 zeros. So if you see 5 zeros in the RS1 field, then that means it is an x0. So don't confuse this with the data. The data is not 5 bits. The mapping here is 5 bits. So if you have, for example, 00001, it means that the source register is x1. So you got to go to x1 and read the 32-bit value from x1. So that is what this means. So if you have x20, x21 as RS1 and RS2, you're going to fill up the 5-bit binaries for that. Then fill up the function field, function 3 field from this particular table here. So all of them are zeros here for add. And then fill up the opcode. Then now what you do is you arrange them in this particular format in groups of 4, then convert that into hexadecimal. So that was R format. Similarly, you have what is called as an I format. I format usually has an immediate field along with it. So add I. So this means that you're going to add x6 to 20. So this is a 12-bit immediate, and you're going to write the destination into x5. So the format for this is you have an opcode, then you have a destination, then you have the function 3, which is again going to be dependent on the type of instruction. Then you have RS1 and immediate. So note that in all of this, what they've tried to do is they've tried to keep the opcode in the same location, which is 0 to 6. And if you look at the previous instruction, they have the RD in the same location, which is 11 to 7. So that's the same place here, 11 to 7. Then the function 3 field is 14 down to 12. That's the same location here as well. Then you have RS1, which is again present in the same location. So everything is very, very similar to the R format, except that now you have a 12-bit immediate field. Then there is a U format instruction. So for example, you have a load upper immediate, RD and constant. So what this will do is it will load the upper 20 bits of this destination. If destination is, for example, X1, this is a 32-bit register, you're going to load the 20 bits of this, the upper 20 bits of this, that is 31 down to 12, with the immediate value. This immediate value is a 20-bit immediate. You're going to load the upper uh, upper immediate. That is what it's called. It's load upper immediate. Load the upper 20 bits with the immediate value and set the other bits to 0. So if you want to load a 32-bit value using an immediate instruction such as LUI, how can you do this particular load? So this is something you can think about. So think about how you can load a 32-bit immediate using LUI into a register. Of course, you cannot do it just with one instruction. You'll have to use another instruction in addition to this in order to do that particular operation, and then we can discuss about it.